Good afternoon, everyone. Today I'm very excited to be here to talk our project from GitHub to governance, the continuous evolving human AI technology of taxonomy of AI technologies. So this is the joint work with my wonderful team members, AJ from UBC and Mario DK from BU, as well as Reina from University of North Texas. As we all know, recent years we have seen a really explosive growth of AI. According to this Stanford report, there has been a number of, from the year of 2013 to 2023, the numbers of AI publications has doubled. Meanwhile, the number of AI patents has ballooned from 5K to more than 100K. And then consistent with this explosive growth of AI, there has been a involving attention, growing attention from the policymakers on how to govern or how to regulate the AI. Right? So just in last year, there has been in total 221 bills being introduced to the US Congress, but however, only 4 of them has passed. And similarly, the DOJ and the FTC has taken a lot of measures and trying to regulate the AIs. There has been the news has came that there has a broad investigation into the big tech companies. But in contrast to this growing attention from policymakers, there has been the status or some of the concern from the policymakers and from the academic. Right, so last year there has been an attempt to build some sort of taxonomy to classify the AI technologies, but however, even that kind of classification system is very static. So as you can imagine, with LLM generating the new category of technology every week, this brings the issue of this static, taxonomy of the AI because. It's essentially the development technology is outpacing the enforcement framework. And we like to, and in our opinion, I think the static AI taxonomy can bring really about the governance of AI. So the first impedance to the AI governance is essentially about what are we regulating, right? With all these delayed regulatory reactions, we simply do not know what kind of technology should we regulate, right? So let's imagine there's some risky technologies that exist long before, but with this static AI taxonomy, we don't really know they exist yet. And the second question is about misdirected enforcement, right? With the current static AI taxonomy, we don't really know who are the one we should regulate, right? So without this kind of map, the knee-jerk reaction of the regulator would be just targeting the biggest player in the AI space. We're going to target, big tech. We're going to target the OpenAI or, all these, emerging companies. But what we want to say is that the enforcement or regulation should be targeted on the functions of the AI rather than the firm size or who are they regulating, right? So. This kind of misdirected the enforcement will create a risk that's basically penalizing the very entities and making a lot of contributions to the AI. And the third question or third impediment we're concerning about is the lack of empirical evidence. The current regulation is largely based on fears, not necessarily about data. So that means that it requires a kind of atlas, a kind of map, that to map the development, the real world development of AI versus the mishap and the potential risk. So for this project, we're really focusing on the first two problems. We're building a taxonomy to figure out what we are regulating and who are we regulating. For the third question, we're read out the next here. All right, so in this paper, what we are trying to do is to create a continuous evolving human AI taxonomy of AI technologies. The idea is simple. We're building a multi-agent system that's automatically, annotate and create this taxonomy of AI technology that has to keep evolving, right? So basically, the input to our model is first, it includes open source code and documentations, as well as some academic articles that's related to AI. And we build a multi-agent framework, with the annotator, with the critic, with all the guardrails that help ensure the quality of the taxonomy is good. So the output of this, of course, we're also going to introduce, some human experts, to put there to, ensure the quality, so that the whole output of this taxonomy, the framework is going to be first. It clearly identify what is, for each of the company at each of the time. We're going to identify what technologies company are working on. And second, based on the keep evolving technology, as you can imagine, we can map in this AI space who are the major players that are creating this taxonomy for each of the company, what kind of technology they are producing, and hopefully we'll also get map about the dependencies between different technologies and how they are evolving, and we can compute the kind of to characterize this dynamics. So this kind of a framework will have multiple capabilities. So the first thing that enable is to allow us to track what AI is emerging and how fast it's growing. The second thing it's enable is just identify exactly who is building which kind of technologies. So traditionally, when the economists or the regulator they define market, they largely based on the product market, right? But in AI space, it's really vague to define what kind of product. So it's going to be very problematic. So, however, this is the reason why we need to create a taxonomy for the taxonomy. And of course, this kind of a model is also allow us to pinpoint the most influential components and the actors and measure the market's concentration in specific AI domains. Now I will give an overview of the algorithm. So essentially, our algorithm is is basically parallel to this taxonomy of animals, right? Think about when the biologists see a bunch of species. What essentially the first thing to do is collecting, the sequencing, the biomolecular evidences from it, right? So you got the protein sequencing, you got the DNA data, and then they send out a bunch of data into classification algorithms, and then they do some hierarchical clustering, and that build a kind of a polygenetic tree, which is which is the basis for them to build this taxonomy tree. And once you got this tree structure, as you can imagine, when all the species are being found, there's a constantly changing or kind of revision to the taxonomy, right? So, for example, sometimes you might find a certain family or certain genesis are too big, then you might want to split it. And sometimes you find there are certain families or need to be merged, and then you do some revision and maybe merge them. So we're doing the similar things for the AI taxonomies. Essentially, the code, the documentation are like the DNAs of each of the AI taxonomy. We have the AI agent that are going through this code and documentations, and we got their representations, and we also use some clustering as to create this taxonomy tree. And of course, we also keep making revision to the AI taxonomy tree. Sometimes we split it, and sometimes we merge it. So for our project, for now, we're using we're testing our algorithm on the GitHub repos. So specifically, we're focusing on the most popular GitHub repos from the organizational accounts. So essentially, those are the repos that have more than 250 stars, and all the top organization agents with more than 1,000 stars. So totally, this counts for. And after running through all the repos, we find that 80% of them are AI related. So after running this algorithm, this ends up giving us a hierarchical tree of the taxonomy. We do some revision, we do some clustering to reshuffling the structure. So this will get the hierarchical structure that have the 3-level steps. One thing I want to note is that our taxonomy is not mutually exclusive, meaning that there could be a repo who can belong to multiple different taxon, right? You can have a repo that is about robotics, but at the same time related to neural network. So that is totally possible. So as you can see, most of the repos on the GitHub or focus on the neural network and statistical machine learning. So those are the most popular categories. Here are just an overview about the taxonomy. For example, this is a microcluster of a deep neural network. We have roughly 7 different microclusters, and for each of the mesoclusters, we also have several couple thousands or even hundreds of concepts. This is also an LP for optimization, just for reference. Next, I want to give some sort of analysis or some demonstration about what kind of thing we can infer using the taxonomy system. So I want to begin with overall statistics of the big tech AI. So first the thing we'll find that the GAFAM as a collective was initially not really keen into the open source until the year of 2015. Overall, it holds less than 20% of all the AI, open AI repos. But however, their share becomes significantly larger if we only focus on the 4 profit companies. Another thing here is the market entrance across all the AI domains. So from this, using the taxonomy we have inferred using our framework, we find that historically there are 2 big waves where the new entrants and getting into this AI domains, right? So one is 2016, which is about NLP and the video, and the latter part, the second wave was in 2018, where it's largely enabled by the transformer and all this pre-trained language models. This is also consistent we're finding about HHI index. And one thing really great about taxonomy is it actually uncovers the heterogeneous landscape of AI development. We found that different type of players all carve out some distinct niche in the AI space, but the big AI generally have a strong presenting all those categories. We also find that even within the big techs, there has a different prioritizing AI technologies. For example, Alphabet and Microsoft may contribute across all AI domains, and maybe Meta and also have a heavy focus on the deep learning. We also find that timing-wise, they have the different strategies, where Amazon and Microsoft were earliest movers, but they were later replaced by Alphabet and Meta. Also did some analysis about the cooperation network on the GitHub repos. We find that sometimes the companies or developer also being very collaborative, and you will find that some of the for those who have the highest impact in this on the GitHub are not necessarily our big tech companies. They're academic institutions as well. Chip manufacturers also very important. So those were just some of demos, but we believe this AI taxonomy too has a lot of applications you can use to map the market concentration. As I mentioned before, you can also use to identify the emerging technology and the potential risk. You can also use this to kind of measure the AI supply chain to analyze the network dependencies or identify the critical components of AI and flag the systematic risk. So time is up. I'm very happy to take the questions, and any feedback is welcome.
We have some time for 2 questions.
Yeah. Mm-hmm. You're saying why is it that the governance is very important for the taxonomy? Oh, so we want to make it clear that the current regulation. So I will have to talk about this in this slide. So a lot of the regulations are to have a clear, really good AI regulation. You need to know who is making this regulation, who is making all the contributions in the AI space, what kind of technologies they are contributing. you don't have a good knowledge of that, it's impossible to get like a more precise or targeted innovation or regulation over the AI space. Mm-hmm. Mm-hmm.
Some of the major players are missing from there because I think you are only focused on
Yeah. Mm-hmm. Yeah. So this is the current step where we only work on the open source, but this framework can be used of virtually any kind of textual data. I could work on pattern or any kind of maybe the Hugging Face, large language models, as well as some AI products.